Alright everyone, I have been chosen to do problem 36 from chapter 33, and it reads, what is the net force, magnitude, and direction on each wire in the figure? And I have drawn the figure here for you. We have 3 wires, all with 10 amps going through them. The second wire has 10 amps to the left, while the other 2 have 10 amps going to the right. They're separated by 2 centimeters in the middle, and they're each 50 centimeters long. So what I've done here is just drawn it a little bit differently, as if the wires were rotated and now we're looking directly at them. They're still 2 centimeters apart, and we're just looking right down the wires. So this one, the current is coming at us, while this one, the current is going into the page. So what I've done here is also put the net magnetic fields on. I can show you how I do this. I do this using the right hand rule. So just for a few of them, we'll look at point 1 here. To get the 2 forces on point 1 from the magnetic field, we do the right hand rule. So here, the force from 2 on 1, which is this one here, we want to put our thumb in the direction of the current, so that would be down, and then we curl around to get the magnetic force. So now we're going to the right, as you can see, down, and it's going to be hitting right here and to the right. And then also for 3 on 1, so we look here, current is going up, and we're going to be curling around and hitting it right here and going to the left. So that's how I did all of those. It comes out. Here they are. Now what we need to remember is that B due to a wire is equal to mu naught it's equal to mu naught I divided by 2 pi times the distance, where the distance is the distance between the wires, I is the current, mu naught is the 4 pi times 10 to the negative 7th, which is just that constant. So I've already calculated all of these out. It turns out that because the distance between 1 and 2 is the same and 2 and 3 is the same, we have 4 of these that are actually the exact same magnitude. They're not the same direction, but so it turns out that B2 on 1, B1 on 2, B3 on 2, and B2 on 3 are all equivalent, and they're equal to mu naught I over 2 pi d, so 4 pi times 10 to the negative 7th times by the 10 amps divided by 2 pi, and they're all the same distance, that's why they're the same magnitude, so that'd be 0.02, and that comes out to equal 1 times 10 to the negative 4th Teslas. So that's each of these 4 are 1 times 10 to the negative 4th Teslas. The other 2, 3 on 1 and 1 on 3, are equal to mu naught I over 2 pi d again, which equals 4 pi times 10 to the negative 7th times by, again, 10 divided by 2 pi, and then the d now is 4 centimeters for each of these, because from 1 to 3 it's 4 centimeters, so we'll put in 0.04. That turns out to be 5 times 10 to the negative 5th Teslas. Now when we're doing the net magnetic field on each of these, we look at 3 on 2 and 1 on 2, and we notice that 3 on 2 and 1 on 2 are the exact same, but in opposite directions. So we can easily see now that the B from wire 2 is just going to be 0. So that'll be B for wire 2. But wire 1 and wire 3 are not, because we have these 2 that are different. So if we're going to do wire 1, we're going to have B2 on 1, which is 1 times 10 to the negative 4th Teslas, and that's to the right, minus B3 on 1, which is 5 times 10 to the negative 5th, and that comes out to be 5 times 10 to the negative 5th Teslas. But that's to the right, so we'll make sure to note that, because we need this when we're finding the force. For wire 3, we have, again, these 2, so 1 on 3 is down here, it's actually 5 times 10 to the negative 5th, and you're going to be subtracting the 1 times 10 to the negative 4th, And so you get 5 times 10 to the negative 5th, but that is to the left because 2 on 3 is bigger. So, now when we're doing the force, we have a cross product in here. So force is equal to IL cross B. With this, it's always really helpful to use the right-hand rule again. This is the right-hand rule. To find the force, we know that B net up here is to the right. And we know B net down here is to the left, and of course B net here is 0. So for wire 1, we have IL cross B, which is going to be 10 times the length, which is 0.5, because it's 50 centimeters. And to do the cross product here, now we're going to use the right-hand rule. We put our index finger in the direction of the current or length, which is going to be up, and then our middle finger in the direction of the B field, which is straight to the right, and our thumb points in the direction of the force, which is up. So that'll be the force there. And the angle between them is 90, so the cross product just goes to 0 because sine of 90 is 1. So then you times by the net magnetic field from wire 1, 5 times 10 to the negative 5th, and you come out with 2.5 times 10 to the negative 4 newtons up. Wire 2 we know is now 0 because B is 0, and so when you cross something with a 0, you just get 0 newtons for the force. Now wire 3 is again non-zero, so the force here is equal to 10 amps times 0.5, and it's again going to be 5 times 10 to the negative 5th, and that obviously is the same answer, but we have a different direction. We'll show you here using the right-hand rule. So our index finger in the direction of the current or length, which is straight up, and the net magnetic field is to the left, so we've got up and to the left, and our thumb points down. So the force here is down, and you come out with down. So there are your 3 answers. It's 2.5 times 10 to the negative 4 up for the wire 1, same for wire 3 but down, and 0 for wire 2. Thanks.